Alright, so Chapter 6 Preparation Quiz. This is your longest, hardest, and most important quiz. It is, majority of this will be on this will all be on the midterm, but the bulk of the midterm will be the Chapter 6 Preparation Quiz, especially standard, normal, and the normal distribution. Most important things in this course. So, it's a long quiz, but let's get at it and make sure you practice a few times through the week. So, question number 1, 10 multiple choice questions, 4 answers to choose from each. Student guesses blindly for each one. You know, what's the probability that he or she's going to get something right? So first thing you realize, this is a binomial. There are 10 trials. Probability of getting any trials right is 1 out of 4. It's the probability of getting a question right. Probability of success in any trial. Your expected value of x. Now recall that for any distribution you have given properties for the binomial distribution, and this is a review problem. Back to chapter 5. This is discrete probability distributions. One of the properties that's given to you when something is a binomial distribution is expected value. It's n times p. So we can just use that formula and solve for the expected value. Variance of x is also a given property for the discrete binomial distribution. It is n times p times 1 minus p. And in other instances, 1 minus p will be referred to as q. This is the probability of failure. But in this class, we're not using q right here. We're just sticking 1 minus p. So a little background knowledge. You never know what they're going to do in the next sequence of this, or the next course of this sequence. Standard deviation of x is always the square root of the variance. Looks good to me. Alright, so let's start solving for the probabilities. And first thing you notice is I have these right here. That's not going to be given to you. I have them there to save time. And it's set up like this. These are your inputs, sort of. Here's your calculations, and there's your final result at the end to get the probability of x successes. So out of the 10 multiple choice questions, f of 3 represents the probability that you're going to get exactly 3 right. So let's start by figuring out what f of 0 is. In this case, the input would be 0, n minus x, and this is going to be equal to n. That stays constant, so, and the location that doesn't change, so we're going to lock it in place with the dollar signs. Subtract x, that is not locked in place, so n minus x in this case is 10. NCX, it's a combination, and you're picking from n, lock that in place, and the number that you're choosing is x, leave that unlocked. So probability of an x number of successes in a row, p to the x power equals, here's our p value right there, lock that in place, and we're going to take that to the x power, and your 1 minus p to the n minus x, just put in 1 minus p to the n minus x, and I'm not putting that last part into the dollar signs, so let me zoom in a little bit. Now we did these calculations. This formula is given to you, and it calculates out the probability that will be exactly x number of successes in n trials, or x questions right out of 10. And I think the easiest way of doing that is solve for the combination component, the probability to the x component, and the 1 minus p to the n minus x component separately right here, and then you get the real probability of the answer by just multiplying all those pieces together. So let's go ahead and just do that, and there we have our probability. probability of f of 0 is 0.056. If we take this out one more decimal place, there it is. So in this problem, the only thing that was really our input is this x right here, and minus x is just dependent on that. And so I like to put this in yellow to minus. That's the only thing that's really changing, since our n and our p, doesn't really change for these questions right here. So moving on, probability that x equals 1. This is the same notation as f of 1 right here. You probably started out with this in your quiz workbook. That's because my first attempt at this video did not upload correctly. So I'm just going to copy these formulas down and put them in the next column, because the process is exactly the same for figuring out whether f of 0 or f of 1, probability of 0 questions right or 1 question right. Calculations are just the same, except what's different is x. And now you can see right here is the probability, f of 1, probability that you get exactly one question right. There you go. And so, we've effectively created a calculator. You got to make sure you're very careful with your dollar signs and what you lock into place. But, part of this course is definitely being able to do that. So, anyway, there's our f of 1, probably getting one question right. We can do the same thing and solve for f of 2. Probably 2 questions right out of 10. And now f of 3. Copy, paste, 3, boom, set that equal. Looks beautiful to me. Now f of 1, big F of 1. What is big F of 1? It's a cumulative distribution for when x is equal to 1. It's the probability that x will be equal to 1 or anything less than 1. And in that case, that is equal to, there's only 2 different ways that you can get one question right or less than one question right. That's if you get 1 right or if you get 0 right. So the probability that you'll get 1 or less questions right is just the probability that you get 1 right plus the probability that you'll get 0 right. There we go. And f of 2 is the same thing. Probability that you're going to get 2 or less right. Go ahead and sum the probabilities that you're going to get 2 or less. F of 3, same thing. Sum it. There we go. Looks beautiful. Probability that you're going to get 3 or more correct. Now, this is a little bit tricky because I guess what you could do is you could copy this out and do, all the way to 10 and then just sum 3 and up together. But, so we're not going to do that, but I think for demonstration purposes, pretend this, goes on together, and then you could just sum this all the way up to 10. That's in Excel, something you can do in Excel. It's easier if you're just doing it by hand. In other classes, what you're going to have to do to solve this problem in pencil and paper is, I'm going to keep that there, is solve the converse of that. Find the converse, and then the total probability is equal to 1. So 1 equals the probability that you're going to get any number correct from 0 to 10. That's your total probability. And you can divide those events up. You could divide it in half. What's the probability that you're going to get maybe 0 to 5 right? Or the probability that you're going to get 6 to 10 right. Those 2 different probabilities is going to equal 1. In this case, let's divide it in such a way so that we have the probability that x is greater than or equal to 3 in there. So I'm going to copy this. And total probability, we know that 1 is going to be equal to the probability that x is greater than or equal to 3, or I should say, and the probability that x will be less than 3. Right? Yep. Now let's put a little space to make it a little more aesthetic. So the real question is, what is the probability that x will be less than equal to 3. And the way you can think, so the probability that you're going to get less than 3 right on this exam, that's actually equal to, let's spell it out for you. That's actually equal to the probability that you're going to get x is going to be less than equal to 2. Alright, because you're going to get less than 3 right. The largest number of questions you can get right that is less than 3 is 2. And, you know, one way to see this visually, again, pretend that that goes out to 10. Your total probability is the probability that x is going to be greater than or equal to 3, so whoop, 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 all the way out to 10, that guy. And then you have to add the probability that x is going to be less than or equal to 3. That's all these right here. So, you know, that's how you can kind of see that the probability of x being less than 3 is the probability that x is going to be less than or equal to 2. Remember, this is discrete, so that's why that's the case. Now, we can rearrange this formula, and, well, let's start by saying probability that x is going to be less than or equal to 2 is equal to big F of 2, right? So now we can take this formula and instead of using f of, you know, probability that x is less than 3, which is kind of confusing, let's put f of 2 in there. That was due to this line right here. And now we can just rearrange this formula. If we subtract big F of 2 from each side, then, you know, we can solve for the probability that x will be greater than or equal to 3. So I'm going to move that right here, take that out, subtract it from the other side. There we go. So now we see that the probability that x is, you know, greater than or equal to 3 is 1 minus the probability that x will be 2 or less. So that is our answer. There's f of 2 right there. Or what we can do is we can state that this is equal to 1 minus f of 2 and point to this cell. Same answer. Probability that x is greater than or equal to 8. In my mind, the easiest way of doing that is to punch it in. So we're going to put these in here. 8, 9, 10. Probability that x is going to be greater than or equal to 8. Sum greater than or equal to 8. And, well, it looks like it's 0. Does that make sense? So we'll bring this out a little bit. Now we can see, you know, the probability of someone getting 8 problems right, they're blindly guessing on 10 of them, is 0.039%. 0.4%. Crazy. So, guess if you don't know anything, probability of you getting a, you know, 8 or higher, which you could say is a B or better, is, let's just change that to a percent, 0.404%. Sorry for the tangent. Alright, so the Poisson distribution. Auto insurance claims for an individual policy are reported at a rate of Poisson rate of gamma equals 1 per year. Answer the questions, recall x exclamation points, x factorial, use the fact function. So, calculate the probability of 0 claims in a 1 year period. And what you're going to be getting for a Poisson distribution is the probability density function, which is right here, PDF, and it's as simple as plugging and chugging away to get your answer. When you're doing a Poisson distribution, the first thing you want to always figure out is what your x is, and that's, in this case, you know, we're concerned with the claims. X represents claims, and look to the problem. Now what's given in the information, look at the question at hand, and to figure out what X is. So, 0 claims. Now, once you figure out what 0 claims, ask yourself, what's the interval that we're interested in? So, 0 claims in what interval? In this case, the interval is a 1-year period. And so we say, the mean right here, mu, represents the average number of claims in that interval. The interval changes based on the question. We'll see that down here. In this case, the interval is the same amount of time that's given to you in the problem, a year. So our interval is a year. What's the average number of claims for that year, or the mean number of claims? 1. And now we plug and chug away. Mu to the x, e to the negative mu, and what you want to use for e to the negative mu is your exponent function. Returns e raised to the power of the given number. So the number that we want to give is negative mu. Don't forget that negative sign. There we go. And x factorial, which you remember, x factorial is just x multiplied by x minus 1 multiplied by, that number minus 1 again. For example, 3 factorial is 3 times 2 times 1. We can just use the function. Factorial of x, factorial of 0 is 1, if you did not recall. And now we just want to plug and chug to get the probability, in this case, when x is 0. So, f of x equals mu sub x multiplied by e to the negative mu divided by x. And, again, this stuff right here, that's not going to be given to you on the quiz. Here's kind of your input section, and what's known. Here's some calculations, and I say, you have to realize the end result we're looking for is f of x, so we need to come up with this equation somehow. I think it's easiest to put this entire equation together if you break it up into 3 different parts. Part 1, part 2, part 3. Then we, multiply the first 2 together, divide by the third part, here we have our equation. And in the result, we have a little calculator for the Poisson distribution. That's beautiful. So, let's go down. Calculate the probability of exactly 1 claim in a 2-year period. Alright, so we're going to start out with this again, since the framework's the same. We're going to delete this. What happened there? Where am I? Delete this, delete this. The equations don't change, our inputs just change. And now we say probability of how many claims? 1 claim. X is 1. And now remember, the second thing you ask is, what's the interval? What's the interval for 1 claim? In this case, 2-year period. So now this is the average in that interval. It changes as your interval changes. The last problem, our interval was 1 year. In this question, the interval is 2 years. And so we want to ask ourselves, what is the average number of accidents in 2 years? Let's look back up at the problem. Oh, the Poisson rate is 1 per year. So the average for 2 years is simply 1 times 2. 1 per year times 2 years. Put a little equal sign there. There we go. And now, this process is the same as the first question, and we can come up with our probability of exactly 1 claim in a 2-year period. Beautiful. calculate the probability of at least one claim in a 2-year period. So once again, you're not going to have any of this stuff. I have it to save time. We want that the probability that x is going to be greater than or equal to 1. There's only one way to really figure that out in this case, since you can have potentially infinite number of claims in a 2-year period. But so what we're going to have to do is, instead of calculating out the probability of one claim plus probability of 2 claims plus probability of 3 claims, we have to figure out the converse of that, and then take 1 minus the total converse. So that is what we are going to do. And first you can come up with a statement for the total probability, which is saying probability that x is going to be greater than or equal to 1 plus probability that x is going to be less than 1 is equal to 1. And then, you know, if we subtract, we want to get this by itself because that's what we're looking for. So subtract the probability that x is going to be less than 1 on each side. Get the probability that x is greater than or equal to 1 is going to be 1 minus probability that x is less than 1. Probability that x is less than 1 in this case, what's the only way you can have less than 1 accidents? If you have 0 accidents. So that's this line right here, and you can sub that into this guy right there. Probability that x greater than or equal to 1 is simply total probability 1 minus probability that x is equal to 0. So the probability that I'm going to have 1 or more accidents in a 2-year period is simply 100% minus the probability that I'm going to have 0 accidents in a 2-year period. That's exactly what is going on here. So we want to solve for this guy. We can do that in this case. I'm going to take these formulas, copy and paste them. We're looking for 0 accidents in a 2-year period. Don't forget about this mu. That can be tricky since intervals are changing, but in this case the interval is the same amount as that, and so mu is also the same. And end result is probability of 0 accidents is 0.135. Notice that's different than the probability of 0 claims in a 1-year period, obviously, because now we're talking about a 2-year period. So be careful with that mu again. And probability of 1 or more accidents is just 1 minus probability of 0 accidents. Beautiful. Now here we go. For a 5-year period, calculate out the probability that x is going to be greater than or equal to 2, less than or equal to 4. Easiest way to do this, in my humble opinion, is make our calculator. Now, let's take this guy out, and let's just solve for the probability of 2 accidents in a 5-year period first. So there's our 2 accidents, and now we want to say the average number, what's our interval? 5-year period. What's the average number of accidents that happen in a 5-year period? That's what this mu is. It's 5. Now we have the probability of getting 2 accidents in that interval, and we are interested in between 2 and 4 inclusive. So that's 2, 3, and 4. Just copy this over, change this to a 3er, change that to a 4er, and just sum them together. That's it. Poisson distribution under your belt.